So we can say that it's the same reactions as in OChem. But, this is a really important but, they're applied under physiological conditions. What do I mean by physiological conditions? Well, I mean these have to occur under 1 atmosphere pressure. Okay? You can't, it's not like in the OChem lab where you can put it in a pressure reactor and jack the pressure up to, 37 atmospheres of nitrogen. Can't do it. Got to do it in 1 atmosphere. You got to do it at 37 degrees C, right? Or something similar, right? I can't put this in refluxing bone dry acetonitrile in a condenser apparatus at 90 degrees for 7 hours. Can't do it, right? Got to do it at 37 degrees. Furthermore, I have to do the reaction in 55 molar H2O. Now, I have 2 comments here. First, I'm from Baltimore. The way I say H2O is water. Many of you say it the way my wife does, which I think is water. I can't say it her way. So when I say water, you know what I'm talking about, right? If you're from Philly, you say it the same way. 55 molar water. I can't do this in benzene. I can't do my reactions in toluene. I have to do them in 55 molar water. And then the last aspect of biochemistry that I really want to stress that's super important is it's enantiomer specific. And what do I mean by enantiomer specific? What I mean is if we consider a common biochemical reaction, a reaction that we're going to talk about in great detail over the course of the semester, we're talking about the breakdown of glucose in muscle, and what we end up with here is pyruvate or pyruvic acid, and this gets converted by an enzyme known as lactate dehydrogenase. This detail doesn't matter. We're going to cover this in great detail later. What we end up with when we do this is this molecule. Okay? Not, okay? I only get this enantiomer, L-S-lactate. Okay? This is what accumulates in your muscle when you do too much exercise and makes you hurt. Okay? So it's enantiomer specific. Now, this is important because if I were to give you pyruvate and tell you I want you to reduce this ketone to an alcohol in the lab, it would be very challenging if I said I want you to do that reduction and I only want you to give me the L isomer. Huh? You know, if you do this in most ways, you're going to get a mixture of the L and D isomers. And I'm telling you, I only want this one. So there's something very unique about how biochemistry catalyzes these reactions, and it has to often do these kinds of reactions in clever and non-obvious ways. And all of these reactions, interestingly enough, as I said, have to be done in aqueous solution. They have to be done in 55 molar water under carefully controlled conditions, particularly pH. And so if we're going to study these kind of reactions, the ability of a particular enzyme to convert pyruvate to lactate, we have to do it under conditions where we can control the pH of the solution.